Hello, in this tutorial I'm going to talk about ESP8266 microcontroller programming with Arduino IDE. In this video, I'm going to show how to implement a Wi-Fi manager to connect to a Wi-Fi access point. So the idea for this project is that when we develop an IoT application, usually we're going to connect to a Wi-Fi router. So for example, we have ESP8266 here. To be able to connect to the internet, we're going to need a router or a switch, Wi-Fi router, so that we can communicate or we can store or access content from a remote database. So for example, this ESP8266 connected to a sensor ESP86 temperature sensor. So the data that collected from the sensor, such as temperature and humidity, are then required to be transferred to a database, stored to a database. So to be able to do that, this microcontroller will be required to connect to the internet through a Wi-Fi access point. To connect to a Wi-Fi access point, will be required to have SSID for the router and also a password. And usually that can be achieved by using static reference for the router information. However, if you move the ESP8266 to a different location or to a different router, you need to recompile the code and then set with the new access ID and password. So in this project example, I'm going to show how to dynamically change the access point information by using Wi-Fi manager. So consider the following program. For ESP8266 to work, we're going to need 3 libraries and EEPROM library. And then we need to define server object for ESP8266 web server, which is later on will be used for implementing web server. And then we have 2 variable SSID for and password for the SSID credential, and content here to build our HTML page. The AP mode variable here is used to define the current access the current mode for the ESP8266. So the code start by setting up the device. Let's start with read the data from EEPROM memory. So the read data method here responsible for loading the credential information from memory. So when you have EEPROM, such as features provided by ESP8266, which allow you to write and read data from it. So reading data from EEPROM basically is quite simple. So what we need is just a loop to read each of the memory location. So for this, the first loop here responsible for the SSID name, and the second loop here for the Wi-Fi password. SSID contains 20 character long, which is the maximum character. So if you need to change to a different length, so you can do it here. For password, you have 40 character long, so which allow you to store 40 character long password. So once we read the data from EEPROM, then we can test the data. If SSID data or SSID variable contain more than 1, or if it is equal 0, which is contain no data at all, we set the device into AP mode. So this AP mode here, AP mode function here, turn the device into what we call as access point mode. So we set the AP mode as true, which is the current mode of the device. Define the ESP8266 name for the device, and then set the password to no, and start the access point mode by using this instruction. So once we have the access point mode turned on, the device will enable its access point mode, which allow for any computer to connect to this address by using network. All right, so now we have the access point mode turned on, and here also we have the launch web, which is to enable the web server application. So the launch web here execute two parameter. Launch web 0 means that we set the web type, and also we execute the create web server function, which is at the bottom here. So the create web server function is where we set the return request of the server with HTML page form. So this is basically just a simple HTML form that allow user to enter their credential and view their current credential. The second server on here, this is basically responsible for the submit button. When user press on the submit button form that basically defined in the return statement in this page here, it will basically get the value from the form and then send to another function to write data into EEPROM, which is handled by write data function down here. So the write data function here is a function to store data into EEPROM memory. Okay, so the EEPROM memory here will basically do the same, but except writing or write the data that we have, or we pass the SSID and also the password here into EEPROM write. So again, remember the character longs here, 20, 40. So make sure that the SSID and password is equal or less than 20 and 40 character long. So once we have that, store the data into EEPROM, and then we can send back the return result back to the browser and then restart the device. Another function here is basically just to reset the memory or the EEPROM memory with reset function, which is to clear data. So this is just to clear all the data available all the credentials available in the EEPROM memory, which is here. So it just basically loop 512 memory address and then remove or write this with 0. And if the SSID is not equal to 0, then we can use this test Wi-Fi function to check or to try to connect to the Wi-Fi. So the test Wi-Fi there basically allow us to try to connect to the access point. So here what we have is to set up or start disabling any access point mode, and then set the mode to Wi-Fi mode. Try to connect to the SSID by using the credential, and then finally check or test the connection if it is a success or not. So this is what the test Wi-Fi function is all about. It returns true if we successfully connected to the router, and it returns false if it is not. So if the Wi-Fi mode, the test Wi-Fi connection is a success, then the AP mode will return to false. If the connection is failed, then the AP mode is true, which is we'll call again and turn the device into access point mode. So that is in the setup function. In the loop function, we have the following instruction. So this is just basically to allow user to select or to choose access point mode through the use of a switch. So here we use digital read D3, which is available on the known MCU device through the flash button. Flash button. So the flash button basically allow for the device to read, since the ESP is the digital pin is a high-low, which is high is equal low and low is equal high. So that's why we have digital read equal low, means that we press the button. If we press the button, then we turn on the access point mode. Okay, so we can turn on the access point mode, and then even though there's a connection to the router, we can turn it off and then set it again into access point mode if you want to reconfigure. Alright, so the rest is just to listen. If the AP mode is true, listen to the incoming connection, and then allow user to receive the HTML page form. And the rest is if the status is connected, then you can perform your logic here. So if you want to connect to database, if you want to receive and return data, so this is where you do your logic. Alright, so let me show you how it works. So we have connected to our ESP8266 board. So by default, if we press the reset button, it should try with the default SSID, which is available in the EEPROM memory. So in this case, we have Wi-Fi guest. So with empty password, try to connect this for 50 times, as described or shown in the test Wi-Fi here. So I've set with 50 times. So if you want to reduce the number of test time, you can reduce from there. So try to connect 50 times, and each time with the delay of 900 milliseconds. So you can fine tune there to improve your Wi-Fi connectivity. And if it is unable to connect, it will return into, or it will set as an access point mode, as you can see here. So if fail to try to connect to the Wi-Fi available in the read data here, it will it will automatically enter access point mode. So the access point mode should allow for user to connect to available network, such as defined network here, ESP8266 AP. So when we connect to the network, we should be able to access the web server service by using the following IP address. So we have the following page and form. So the page basically contain current setting and will show the current information available in the memory, EEPROM memory, and then new configuration form if we wish to provide one. So for example, if you want to connect to another network, for example, this network, so we can provide with the password. Try to connect, and the device will automatically reboot. Okay, so we can see here the device automatically reboot and try to connect with the new network. If the network is available, let's try to connect to the new network. It will return connected, and then with the provided IP address successfully returned back by the access point. So that is how the Wi-Fi manager works, and it's rather simple implementation, and you can fully customize your web content here, web server content page here. Or if you want to add, for example, device ID or any other credentials that is required by your application, it can be done here. So you can implement the simple Wi-Fi manager in your project and allow your project to be reconfigured and no longer bound to static access point. All right, so that is all for this tutorial. Until next time, bye-bye.